And we now move on to the laws of logarithms. There are four main laws of logarithms. There are four main laws of logarithms. They are the first law, and you should note that it is relative depending on the author. Some people may use the second as the first in their books. Some may use it the third as the first in their books. Some people may use it the fourth as the first, and vice versa. For simplicity's sake, for simplicity's sake, I want us to start with this as the first law. It's normally called the Exponent Law of Logarithms. And that one is like this. That's if you take the log of a certain number to a certain power, the log of a certain number n to a certain power, the log of a certain number p to a certain power n, then to the base a is always equal to the power n times the log of the number p to the base a. With this, we need to prove it. So let's prove it. First, let p be equal to a raised to the power m. Then we name this equation 1. Then with this, in logarithms, it will be m is equal to the log of p base a. Then what we then do is that we multiply or we raise both sides of equation 1. We raise both sides of equation 1 to the power n. And this will give us p raised to the power n being equal to a raised to the power m or raised to the power n. In effect, we will get p raised to the power n being equal to a raised to the power m n. That's from the Exponent Law of Indices. Then the next step is you take the log to base a of both sides. So it will be the log of p raised to the power n to base a equal to the log of a raised to the power m n. Then from the basic principle of, or the basic points of logarithms, with this we will get n log p to base a being equal to m n log a base A. But we know that m is equal to log p to base A, and the log of A to base A is also equal to 1. So when you substitute this into the equation, we will end up getting the log of p to the power n base A being equal to n log p to base A as required. Now let's move on to the next law. That's the law 2. With the law 2, at times it is called, some people call it the product law of logarithms or the addition law of logarithm. What it simply states is that when you take the log of the product of two numbers to a particular base, it is the same as taking the log of the individual numbers to the same base as before. Mathematically, it is expressed as log of a number p times a certain number q to base A being equal to the log of p to base A plus the log of q to base A. Now let's try to prove this one too. As usual, let p be equal to a raised to the power m. Let me name this equation 1. In logarithms, that's by the definition of logarithms, it will be the log of p to base A being equal to m. Likewise, if q is equal to a raised to the power n, being equation 2, then in logarithms, it will be the log of q to base A being equal to n. Then our next step is we multiply equation 1 by equation 2. And this will give us on the left hand side pq being equal to, on the right hand side, a raised to the power m plus n. I hope you understand why it is a raised to the power m plus n. That's from the addition law of indices. When you are multiplying indices of the same base, you add the exponents. Then the next step is we take the log to base A of both sides of the equation. And with this, we will get log A pq being equal to the log of a raised to the power m plus n to base a. Then from the first law of logarithms, this will give us log pq to base a being equal to m plus n, or multiplying a base log a base a. And we know from the noted points that log a to base a is always equal to 1. That's the log of a number to the same base is always equal to 1. Hence, we will end up getting the log of pq to base a being equal to m plus n. Then from the early stages, that's why we said let p be equal to m. We ended up expressing it in logarithm form. And that one we also had m to be equal to log p base a and n being equal to log q base a. So substituting this into the equation, we will end up getting log of pq to base a being equal to log p to base a plus log q to base a as required. Then we move on to the third law. We move on to the third law. And the third law is at times called the division law of logarithms. What it simply states is that when you take the log of two numbers dividing each other, it will always be equal to the log of the numerator to the same base as before minus the log of the denominator to the same base. So mathematically it goes like this. The log of a number, say p, divided by a number q to base a is always equal to log p base a minus log q to base a. Now to prove this one too, you will say let p be equal to a raised to the power m Then we name this equation 1. Then by the definition of logarithms, this can be expressed as m being equal to the log of p to base a. Likewise, we say let q be equal to a raised to the power n. Then we name this equation 2. In logarithms, it will be n equal to the log of q to base a. Then our next step is we divide equation 1 by equation 2. And with this, we will get the left-hand side of the equal sign being equal to being p over q, or being equal to a raised to the power m divided by a raised to the power n. Then from the laws of indices, it will be p over q being equal to, whenever you are dividing indices of the same base, we always subtract the power of the denominator from that of the numerator. So we end up getting a raised to the power m minus n. Then our next step is we take the log of, we take the log to base a of both sides. So it will be log of p over q to base a be equal to the log of a raised to the power m minus n to base a. Then from here, we apply the first law of logarithms here. And you end up getting the log of p divided by q to base a being equal to m minus n, or multiplying log a to base a. Then from the beginning, if you remember, we said m is equal to that by the definition of logarithm. M is equal to the log of p to base a, and n is equal to the log of q to base a. And then the log of any number a to the base a, that's the same base, is always equal to 1. Now substituting all this into the equation, we will end up getting the log of p divided by q to base a being equal to the log of p to base a minus the log of q to base a as required. Then we move on to the fourth law. Now the fourth law of logarithm states that when you take the log of a certain number, say p, to the base a, it will be the same as the log of p to a certain base b divided by the log of a to the same base as the numerator. Now let's prove this. With this, let the log of p to base a be equal to c. Then in the index form, it will be equal to a raised to the power c. Then we name this equation 1. Then, taking the log to base a of both sides, we will end up getting log p to base b. Taking the log of b of both sides, we will end up getting the log of p to base b equal to the log of a raised to the power c to base b. Then from the first law of logarithms, we will end up getting log p to base b equal to c log a to base b. Now making c the subject by dividing through by log a to base b, we will end up getting c being equal to the log of p to base b divided by the log of a to base b. But from the beginning, we said let the log of p to base a be c. What it means is that in place of c, we can put what? The log of p to base c there. Hence, we will end up getting the log of p to base a be equal to the log of p to base b divided by the log of a to base b as required. Now let's try to solve some examples by applying the laws. And don't forget, the questions can be asked in so many ways. You may be asked to simplify a certain logarithm expression. You may be asked to evaluate a certain logarithm expression. Or you may be asked to find an equation. Of involving logarithms. Now first, let's start with the evaluation. say you are asked to solve a question of this nature. Like the question goes this way. Given that the log of 2 to base 10 is equal to 0.3010, and the log of 3 to base 10 is equal to 0.4770. Find without using calculators or tables the values of the following. A. Log 5 to base 10. And don't forget, when there is no base indicated, it means the given base is 10. That by standard. And then B. The log of 3 whole number 1 over 3 to base 10. Now solution. Don't forget, we are to evaluate. And when we say you are to evaluate, it means you are to find the value of it. And with the prelims given, we must express the various questions so that we will end up getting the log of base 2, or let's say 2 inside the expression. So if you take the question A, for instance, that we have to evaluate log 5 to base 10. Don't forget, log 5 to base 10 is the same as the log of 10 divided by 2 to base 10. Then applying the division law of logarithms, this will be equal to the log of 10 to base 10 minus the log of 2 to base 10. Then with this, we know that the log of a certain number to the same base is always 1. Hence, the log of base 10 to base, the log of 10 to base 10 is also 1. So it will be 1 minus, and the log of 2 to base 10 is given here. So we substitute in the value as such. Then it will be 1 minus 0.3010, which will end up getting 0.6990. Now with this, I want you to go and try the second question. There are a lot of them in the given notes that you can try. Now let's move on to